Hello everyone. Well, we know by now that completing the square can be a real pain if you have to complete the square every time to solve a quadratic equation. And you know, I've always thought that probably centuries ago there was an old mathematician some summer evening, and he was sitting out on his porch just enjoying the evening and thinking about how his students also did not enjoy completing the square every time they wanted to solve the quadratic formula. And so as he sat out on the side of his porch, he had his rocking chair, and off to the side of the porch there was some sand, and he took a stick and he started to think a little bit, and he etched into the sand ax squared plus bx plus c equals 0. We know that that's the general form of a quadratic equation, and he thought, you know, there's got to be a better way than having to complete the square every time. So as he sat there and he rocked and he thought, well, you know that if I'm going to complete the square, I need that leading coefficient to be a 1. And maybe it is, maybe it's not. All we know is that it's some real number a. But he knew that he could guarantee that it would be a 1 if he divided everywhere by a. And so he did that, x squared plus b over ax plus c over a, and he set that equal to 0. And as he sat there and he rocked, his wife Ethel came outside and she said, I'm going to bake some cookies. Would you like some? And he said, honey, I'm working on something right now. And she says, all I want to know is, do you want some chocolate chip cookies? And he said, yes, that'd be great. She said, all right, you go back to your math. And so he sat there for a little bit, and he knew that to complete the square, he needed a perfect square trinomial on the left-hand side, or on one side of the equation. And he already had the x squared here. And he realized that this constant was just in his way. So he moved it to the other side of the equal sign to get it out of the way. He thought, okay, how do I go about, in general, making a perfect square trinomial? I thought, well, I need to take 1/2 of the number in front of the x, whatever that happens to be. In this case, it's b over a, and I need to square that. And I need to add that to both sides because we need to keep our equation balanced. So he took half of the b over a, squared it, and added it to both sides. And he sat there, and he took his stick in the dust, in the sand, and he continued to write x squared plus b over a x plus, he squared the b, and that gave him b squared. He squared the 2 to get a 4, and he squared the a to get a squared. And so he had that over here, and he wrote it on the right side of the equation as well. And he was happy, and he rocked a little faster because he realized that he had just created a perfect square trinomial on the left side. And he knows that that'll factor the square root of the first guy. He takes this sign right here, and then he takes the square root of what he has here, which is b over 2a. And he squares that. And he notices over here that his students probably wouldn't be very happy right now because he's going to have to add these two fractions. And even back centuries ago, students did not enjoy finding common denominators to add fractions either. So he kind of chuckled at that because he knew his students would have to do that. And so he recognized that the common denominator would be 4a squared. And so he thought, well, I have to multiply here by 4 and a. And I have to multiply here by 4 and a. And so he had negative 4ac plus b squared on top. And he'd always told his students that it's kind of nice to have the positive term first. So he used the commutative property of addition to reorder those. B squared minus 4ac all over 4a squared. On the left, he hadn't done anything. This was still this factored form of a perfect square trinomial. And then he started to rock a little faster because he realized over here he had his perfect square trinomial. This was a nice expression over here. He could use the extraction of roots idea that they'd went over in class, taking the square root of both sides of the equation, taking the square root of the top and the bottom. And as he had told these students, anytime you use extraction of roots, you need to put a plus minus in front of this. And so he had an x plus b over 2a over here. Now, I didn't know what the square root of b squared minus 4ac was, so he just left that under the square root. But he did know that the square root of 4a squared was 2a. And he smiled, and he sniffed a little bit, and he knew that his wife had just about finished the chocolate chip cookies. He could smell them coming out of the oven as he subtracted b over 2a from both sides. And what he found was x equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, his wife comes out with a plate of chocolate chip cookies and a cold glass of lemonade for each of them, and they sit there, and he realizes that he has just come up with an idea that will save students everywhere for centuries to come from having to complete the square every time they need to solve a quadratic equation that can't be factored easily. Now, as I tell my students in the classroom, there probably was no old guy on a porch anywhere with a stick and sand and dust. But as I tell them, explaining how the quadratic formula comes about is a lot more entertaining for me if I put an old guy and his wife and some chocolate chip cookies in the story. I think that's more entertaining than standing here and saying, okay, look folks, we want to solve this general equation, ax squared plus bx plus c equals 0. If we complete the square on it, we need the leading coefficient to be a 1, so we divide everywhere by a. We need the constant to be out of the way. We need it on the other side of the equal sign, so we subtract c over a from both sides. We know we want to create a perfect square trinomial on the left, and so we take half of the b over a, square it, add it to both sides, thus creating a perfect square trinomial right here that we can factor. Once we've got that factored, we do our work over here to clean it up. As I mentioned, we've got to get that common denominator. And it's nice to have the positive term first. So we, as I mentioned, use the community property of multiplication or addition to turn those two around. And then we can take the square root of both sides. And we subtract the b over 2a. Here's our quadratic formula. And just to give you one quick example of how this works, if we wanted to solve the equation 4x squared minus 4x minus 1 equals 0, we write that down, and we want to identify our characters here. We want to identify the fact that a is 4, b is negative 4, and c is negative 1. So we remember our formula, x equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And if you've already listed your a, your b, and your c, then it's very easy to plug in the opposite of b, which is negative 4, plus or minus the square root of b squared. B, again, is negative 4. We're going to square that, minus 4 times a, which is 4, times c, which is negative 1, all over 2 times a, which we said was 4. And so this gives me 4 plus or minus the square root of 16 plus 16. 4 times 4 is 16 times 1 is 16, and a negative times a negative gives me a positive, all over 8. And then we can simplify this. We've got 4 plus or minus the square root of 32 all over 8. I need to break down the square root of 32. 4 plus or minus a factor of 32 that's a perfect square is 16 all over 8. And then we rewrite the square root of 16 as 4 root 2 all over 8. Notice how we can factor a 4 out of my top. These guys will reduce, and so we are left with x equal 1 plus or minus the square root of 2 all over 2. But you can use the quadratic formula to solve any quadratic equation you would like.